Assalamualaikum. Hi, my name is Muhammad Afiq. We are from Group 3. They are going to present about Lab 7 regarding free fall experiment. Free fall is a motion that occurs when only gravitational force acting on the body. So, for under vacuum condition, all body, regardless of their weight, size, or shape, will experience the same value of acceleration, which is equal to gravitational acceleration. The equation that will be implemented in this experiment is U is equal to negative gt, which come from initial equation, which is V is equal to U plus AT, and we substitute the boundary condition. V is equal to 0 since the ball will struck the ground, and A is equal to G, which is gravitational acceleration. For this experiment, we will use three items, that is measuring tape, ping pong ball, and timer.
Experiment procedure, Lab 7. First, the fall height to 200 cm is set, and the experiment is started by releasing the ping pong, and the start button is pressed to start the timer, and the falling time is taken and recorded in table 1. The experiment is repeated for the same height for 3 times, and the experiment is carried out for various heights, which are 40 cm, 80 cm, 120 cm, 160 cm, and the last one 200 cm. That's all.
Good day everyone, my name is Tan Kai Wen, ID BMM252139, and today I'll be presenting the results for Lab 7. In this Lab 7, we have set the free falling height as 40, 80, 120, 160 and 200 centimeters. We have recorded the free falling time for 3 times for each free falling height, and we have calculated the average free falling time for each free falling height. Next, we have calculated the velocity for each free falling height based on the average free falling time. The data for the experiment is shown here. For the sample calculation, we have taken the height of free falling equal to 40 centimeters. From there, we have calculated the average fall time to be 0.35 seconds. The formula used to calculate velocity is V equal to U plus AT. In the formula, the final velocity V is assumed to be 0 meter per second. The gravitational acceleration A is equal to 9.81 meter per second square, and the average fall time T is equal to 0.35 seconds. By substituting the values into the formula, we have obtained the initial velocity U to be negative 3.4335 meter per second for the height of free falling at 40 centimeters. Next is the graph of velocity versus average fall time. As shown in the graph, the magnitude of the velocity increases as the average fall time increases. Next is the acceleration of gravity AC. The acceleration of gravity is equal to the gradient of the graph. To calculate the gradient of the graph, we have divided the velocity with average fall time. By substituting the values into the equation, we have obtained the gradient of the graph to be negative 9.81 meter per second square. Hence, the acceleration of gravity is obtained at negative 9.81 meter per second square. This shows that the experimental value of acceleration of gravity has no difference compared with the theoretical value. This shows that the experiment has no errors. That is all from me. Thank you very much.
Hello, my name is Danish Hakimi bin Raismadi. My metric number is MA20148. I will continue for the discussion. From the data in table of result and plot graph, what is relationship between fall height and average of velocity? By analyze the data present in table of result and examining the corresponding plot graph, a discernible trend emerged, indicating a direct correlation between the increase in fall height and the corresponding elevation in average velocity of the ball. This observed phenomenon can be attributed to the proportional augmentation in the vertical distance traversed by the falling ball, consequently leading to extended duration for its descent under the influence of gravity. Thus, it can empirically confirm that the fall of height of the object exerts a discernible influence on its velocity.
Hi, my name is Ahmad Nakiuddin Alimi, and I am going to make a presentation about the discussion. So, the assumption and constant values. We made some key assumption to simplify our investigation. First, we ignore the air resistance and focus solely on gravity's influence. Our constant value was the acceleration due to the gravity, which is 9.81 m over s to the power of 2. We also assume negligible initial velocity, simplifying our experiment and eliminating initial kinetic energy. So now let's talk about the relationship we observe between velocity and time. So based on the graph here, the graph is moving toward the expectation 9.81 meter per second squared, symbolizing the influence of gravitational forces. However, we recognize nuance deviation, inherent uncertainty, and potential instrumental limitations. That's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Nabila binti Zaini. My ID number MA20144. Okay, in this video, I will explain about conclusion. Okay, to conclude this experiment, we have achieved the objective of this experiment. We can investigate the free fall from test. We can also investigate the acceleration of gravity. So the height from which an object is dropped and the time of fall do not affect its acceleration. By comparing the obtained acceleration value with the constant value, we are able to account for the experimental errors. This experiment proved that the gravitational field strength is constant in free fall, and in this experiment can conclude the acceleration due to gravity is 9.81 meter per second squared. So that's all from me. Thank you.